Protactinium or protoactinium, former name, is a chemical element with symbol Pa and atomic number 91. It is a dense, silvery gray metal which readily reacts with oxygen, water vapor and inorganic acids. It forms various chemical compounds where protactinium is usually present in the oxidation state +5 but can also assume +4 and even +3 or +2 states. The average concentrations of protactinium in the Earth's crust is typically on the order of a few parts per trillion, but may reach up to a few parts per million in some uraninite ore deposits. Because of its scarcity, high radioactivity and high toxicity, there are currently no uses for protactinium outside of scientific research, and for this purpose, protactinium is mostly extracted from spent nuclear fuel. Protactinium was first identified in 1913 by Casimir Fajans and Oswald Helmuth Goering and named brevium because of the short half-life of the specific isotope studied, namely protactinium-234. A more stable isotope, 231 Pas, of protactinium was discovered in 1917–18 by Otto Hahn and Lise Meitner, and they chose the name protactinium, but then the IUPAC named it finally protactinium in 1949 and confirmed Hahn and Meitner as discoverers. The new name meant parent of actinium, and reflected the fact that actinium is a product of radioactive decay of protactinium. It is noted that John Arnold Cranston, working with Frederick Soddy and Ada Hitchens, is also credited with discovering the most stable isotope in 1915 but delayed his announcement due to being called up for service in the First World War. The longest-lived and most abundant, nearly 100% naturally occurring isotope of protactinium, protactinium-231, has a half-life of 32,760 years and is a decay product of uranium-235. Much smaller trace amounts of the short-lived nuclear isomer protactinium-234 meters occur in the decay chain of uranium-238. Protactinium-233 results from the decay of thorium-233 as part of the chain of events used to produce uranium-233 by neutron irradiation of thorium-232. It is an undesired intermediate product in thorium-based nuclear reactors and is therefore removed from the active zone of the reactor during the breeding process. Analysis of the relative concentrations of various uranium, thorium and protactinium isotopes in water and minerals is used in radiometric dating of sediments which are up to 175,000 years old and in modeling of various geological processes.